A set is a collection of well-defined objects. A set is a collection of well-defined objects. Well-defined means the objects can be identified without any ambiguity the first condition. The second condition, objects are universally accepted. Right? A set is a collection of well-defined objects. For example, example 1, collection of vowels in English alphabet. Collection of vowels in English alphabet. This is the first example. So vowels in English alphabet are A, E, I, O, U. This collection is a set. Then the second example. So guys, quickly note it down. I'll go to the next page. Collection of natural numbers. Collection of natural numbers less than 6. Collection of natural numbers less than 6. So the elements are 1, 2, 3, 4, 5. This is also a set. Example 3. Collection of days in a week. That is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. These are the examples of set. Okay. Then write down the following collections are not sets. The following collections are not sets. Collection of ideal students in Calicut HS. Okay. why the collection of ideal students in collocations is not a set? Because idealism of a student can be measured from different angles. So the collection or elements of this set varies person to person, hence it is not a set. Collection of beautiful flowers in IG Park. Collection of beautiful flowers in IG Park is not a set because the word beautiful is there. Beauty of an object lies on the eyes of the viewer. If for a person rose is a beautiful flower, that flower rose may not be a beautiful flower for another person. Hence, it is not a set. Okay. So, is it clear to you guys? Is it clear? Please write in the chat box. Okay. Then come to naming of sets. Naming of sets. So, ambiguity in Odia that is called dvandva, nirdvandva jota kuhନ୍ତି, without any ambiguity in nirdvandva joti kichi amku kichi jeta kuhaଯାଏ ambiguous case माने जोटी हमें definitely ताको define कर परियानी. Okay, Shobhit. Then come to naming of sets. Shobhit, you are from which higher secondary school? Then come to naming of sets. Write down sets are named after capital English alphabets. Sets are named after capital English alphabet. Sets are named after capital English alphabets such as A, B, C, D, okay, etc. But N, Z, Q, and R should not be used N, Z, Q, R should not be used arbitrarily for the naming of sets. So we can name a set as A, B, C, D, etc. But we should not use N, Z, Q, R for naming arbitrarily a set because these letters represent a particular set. N stands for set of natural numbers. Each of them represent a particular set. N for set of natural numbers. Z stand for set of integers. Q set of rationals. And R set of real numbers. right? For example, A be the set, that is the collection of vowels in English alphabet. So A contains the elements A, E, I, O, U, right? Then come to element of a set. Write down each and every member each and every member of a set is called an element of the set. For example, if the set A contains 1, 2, 3, 4, then we can say 1 is an element of set A, 2 is an element of set A, 3 is an element of set A. It is written like this: 1 EA. This symbol stands for element. Okay. We can read it as 1 is an element of set A, or 1 belongs to set A, or 1 is in set A. 1 belongs to, 1 is an element of set A, 1 belongs to set A, or 1 is in set A. Right? Here 5 is not an element of set A. You can write it like this: 5 doesn't belong to set A. 5 doesn't belong to set A. Okay. Suppose B is a set containing the elements alpha, beta, gamma. We can say alpha belongs to set B, beta belongs to set B, and delta doesn't belong to set B. This is the symbol for element. Is it clear to you guys? Let me know. Is it clear? Write in the chat box. Okay. Then come to representation of a set. That means how to write a set or how to express a set. Write down representation of a set. Representation of a set. That means how to write a set or how to express a set. Write down a set can be represented. A set can be represented in two different ways. A set can be represented in two different ways. One is tabular form or roster form. Tabular form or roster form. The second one is set builder form. tabular form or rooster form. The second one is set builder form. Okay. So in two different ways we can express or we can represent a set. The first form is tabular form or rooster form. The second form is set builder form. So first come to tabular form. How to represent a set in tabular form? So in tabular form, each and every element of the set should be written within a pair of curly brackets, and each element is separated from the other by comma sign. Each and every element should be written within a pair of curly brackets, and each element is separated from other by comma sign. Okay. So come to an example. Suppose collection of vowels in English alphabet. Let A be the set. Collection of vowels in English alphabet. So who all are the vowels? The vowels are A, E, I, O, U. So A, curly bracket starts, A, comma E, comma I, O, U. Second example. Example 2, collection of prime numbers. Collection of prime numbers. Collection of prime numbers less than 10. Let B be the set. This collection of prime numbers less than 10. So B contains 2, 3, 5, 7. Okay. Example 3. Collection of natural numbers less than 5. Let it be set C. 1, 2, 3, 4. Example 4. Collection of roots of the equation collection of roots of the equation x square minus 5x plus 6 is equal to 0. Collection of roots of the equation x square minus 5x plus 6 is equal to 0. X square minus 5x plus 6 is equal to 0 implies x minus 2 into x minus 3 is equal to 0. So either x is equal to 2 or x is equal to 3. Let D be the set collection of roots of the equation x square minus 5x plus 6 is equal to 0. So D contains 2, 3. I hope it is clear to you. Please write in the chat box, is it clear? Then come to set builder form. Okay. Then come to set builder form. In set builder form, instead of writing all the elements inside the set, we should write a law or the formula which is known as the defining property of the elements within the set. Okay. So in set builder form, we should write a law or formula known as defining property of the elements which is also known as common characteristic of the elements those belong to the set. Common characteristic of the elements those who belong to the set. We should write a law or formula known as defining property or common characteristic of the elements within the curly bracket. Okay. So let us come to an example. A is the set containing A, E, I, O, U. Okay. So there are 5 elements. What is the common characteristic of these elements? The common characteristic of these elements, each of them is a vowel in English alphabet. So we can write A is the collection of all X such that A is the collection of all X such that X is a vowel. X is a vowel in English alphabet. X is a vowel in English alphabet. X set of all X such that. Similarly, suppose B is the set containing the elements 1, 2. We can express this set in set builder form as what is the common characteristic? The common characteristic is each of them is a root of the equation x square minus 3x plus 2 is equal to 0. X set of all X such that x square minus 3x plus 2 is equal to 0. Or we can write like this, B is the set of all X such that X is a natural number. X is a natural number X is a natural number less than 3. X is a natural number less than 3. Right? I hope it is clear. So to express a set in set builder form, you have to find what is the common characteristic of the elements, those who belong to the set. That common characteristic should be written within a pair of curly bracket, right? So I am giving you some sets in tabular form. You have to express the sets in set builder form. Write the question, express the following sets in set builder form. Express the following sets in set builder form. Express the following sets in set builder. Express the following sets in set builder form. Express the following sets in set builder form. The first one is, let A be the set containing the elements 1, 2, 3, 4. Second, B be the set containing the elements 2, 4, 8, 16. C be the set containing the elements 3, 6, 9, 12, 15. The fourth one is D be the set containing -1 and 1. The fifth one, E be the set. Okay. So these are the 5 sets you have to express in set builder form. Take 2 minutes of time and send me the answer. X is a natural number less than 5. First one is correct. Priyanka, you are correct. How to express the second one? Hemant, you are also correct. How to express the second one, third one, fourth one? Then third one, x is a multiple of 3 and less than 20, no, Pratisha x Lipsa 2 to the power n belongs to n less than 5. Yes. Lipsa is correct. Okay. Let me write the answers. So question number 1, x is the set of all x such that x belongs to n, x is a natural number, and x less than 5. Right? The second one is the set B contains 2, 4, 8, 16. X is the set of all x such that x is equal to 2 raised to the power n belongs to n, and n less than 5. The third one, C is the set of all x such that x is equal to 3n, n belongs to n, and n less or equal to 5. The fourth one, the set D is the set of all x such that x square minus 1 is equal to 0. And the last one, set E. Set E doesn't contain any element. So we should write in absurd collection where we will not get an element. X is the set of all x such that x is a month. X is a month containing 32 days. Is there any month containing 32 days? There is no such month. Or you can write x is the set of all x such that x is a real solution. X is a real solution of the equation. X is a real solution of x square plus 1 is equal to 0. There is no real solution to the equation x square plus 1 is equal to 0. Hence, that set doesn't contain any element, right? So, these are some examples how to express a set in set builder form, right? I hope it is clear to you. Guys, is it clear? Or D? D is the set of all x such that x square minus 1 is equal to 0. So with x square minus 1 is equal to 0. What are the roots of the equation x square minus 1 is equal to 0? X square minus 1 is equal to 0 implies x square is equal to 1. This implies x is equal to plus or minus 1. Set D contains plus or minus 1. Hence, we can write D is the set of all x such that x square minus 1 is equal to 0. Shobhit, is it clear to you now? Shobhit? Okay, then come to different types of sets. Different types of sets. different types of sets. First one is null set or empty set. Null set or empty set or void set. Null set or empty set or void set. Null set or empty set or void set. Write on a set having no element a set having no element is called a null set. A set having no element is called a null set, and it is denoted by phi. Okay. So in tabular form, the null set phi is written like this: no element within the curly bracket. And in set builder form, you can write in abstract collection where you will not get any element. X is the set of all x such that x is not equal to x. Or we can write X is the set of all x such that X is a boy reading in a girls' high school. Okay. So if phi is written like this within the bracket, then you can't say that it is null set. It is a set where phi is an element. It is not null set. It is not null set. It is a set where phi is an element. This is called a singleton set, right? Then come to singleton set. Null set clear? Singleton set. A set having only one element, a set having only one element a set having only one element is called a singleton set. A set having one element is called a singleton set. यादव जी सर और एक बार बता दीजिए null sets. Null set means beta a set having no elements. If a set doesn't have any element, suppose A be the set, there is no element, we can set it as null set, right? If a set doesn't contain any element, then you can say that set is a null set. Null set extinguish. Extinguish means Hemant. What do you mean to say? Null set means set having no element. If a set doesn't contain any element, then that set is called a null set. For example, A be the set of all x that x is a month, containing 32 days. Yadav, can you say name of a month which contains 32 days? Is there any month containing 32 days? Yadav? Hello? Which month of the year contains 32 days? There is no such month which contains 32 days, hence A is the null set. I hope it is clear to you now. Is it clear? Okay. Singleton set. If a set contains only one element, then that set is called a singleton set. For example, AB the set which contains only alpha, then we can say that A is a singleton set. B be the set of all x such that x is an even prime number. X is an even prime number. X is the set of all x such that x is an even prime number. So the only even prime number is 2. Hence we can say that the set B is a singleton set, right? Then come to finite and infinite set. Finite and infinite set. Finite and infinite set. Finite and infinite set, right? A set containing countable number of elements. A set containing countable number of elements is called a finite set. If the number of elements of a set can be counted, then we can say that the set is a finite set. For example, AB the set containing alpha, beta, gamma, delta. This set contains 4 number of elements. Hence, this is a finite set. B be the set containing the elements 2, 4, 6, 8, 10. The number of elements in the set B is 5. Hence, it is a finite set. If a set contains uncountable number of elements, then that set is called an infinite set. It's an infinite set. A set containing uncountable number of elements, a set containing uncountable number of elements a set containing uncountable number of elements is called an infinite set. A set containing uncountable number of elements is called an infinite set. For example, n set of natural numbers 1, 2, 3, 4. The number of elements is uncountable. Z set of integers minus infinite to minus 2, minus 1, 0, 1, 2 up to infinity. Okay, these are the examples of infinite set. Okay, quickly note it down. Then come to subset and superset. Subset and superset. First write down subset, subset and superset. Let A and B, let capital A and capital B be two sets if each element of set A if each element of set A is also an element of B, if each element of set A is also an element of B, if each element of set A is also an element of B, then A is called a subset of B. Then A is called a subset of B written as A subset B, and B is called superset of A, and B is called superset of A, and B is called superset of A written as B superset of A. A is called subset of B and B is called superset of A. For example, let A be the set containing alpha, beta, gamma, and B the set containing the elements alpha, beta, gamma, delta, right? You see, alpha belongs to set A, alpha also an element of set B, beta is an element of set A, beta is also an element of set B, gamma is an element of A, gamma is also an element of set B. So we can each and every element of set A is also an element of B, but the converse is not true. Each and every element of set B is not an element of A. Here A is a subset of B, A is the subset of B, and B is the superset of A, right? A is the subset of B and B is the superset of A. Take another example, suppose A contains the elements 1, 2, 3, and B contains the elements 1, 2, 3. Here each and every element of set A is also an element of B, and converse is also true. Since we can say A is a subset but not the proper subset. A is a subset of B, but A is not the proper subset. For proper subset, A should be subset of B and A not equal to B. So write down proper subset. So, acha, black color pen. It will be more clearly visible, okay? Let me use the black color and check if it suits you. Then I'll use the black color. Is this color right? Write in the chat box. Is this color suits you and clearly visible? Write in the chat box which color is suitable for you, black or blue. Krishnamayi. This is gray. Okay, then which one is black? I think this one. Oh, proper subset. This color, okay. Krishnamayi. Write in the chat. Okay. This is suitable, na? Okay, then. Proper subset, write down. A is called proper subset of B. Finite and infinite sets. Finite set means if you can count the number of elements of the set, then the set is called finite. For example, if A is the set containing A, B, C, D, okay, here we can count the number of elements of the set. Here the number of elements set is 4, hence it is finite set. This is finite. If in a set we can't count the number of elements of the set, for example, set of natural numbers 1, 2, 3, 4. Okay. Can you say what is the number of elements in the set of natural numbers? The number of elements in set of natural numbers we can't count. It is infinite. Okay. That's why it is called an infinite set. If we can count the number of elements of set, then the set is called finite. If we can't count the number of elements of the set, then that set is called infinite set. Then come to proper subset. A is called proper subset of B. A is called proper subset of B if A subset of B and A not equal to B. If A subset of B and A not equal to B, then we can say A is a proper subset of B. For example, A be the set containing elements 1, 2, 3 and B be the set containing 1, 2, 3, 4. So here we can say A is a proper subset of B. And in IITJ it is written like this, A subset of B and A not equal to B. If it is written like this, A subset of B and A not equal to B, then it says that set A is a proper subset of B. Okay. So come to a question, write down a question. Let's set A is equal to X set of all X such that X is equal to 2n, n belongs to n, and B be the set such that X is equal to 2 to the power n, n belongs to n. Now tell me whether A is a subset of B or B is a subset of A. Tell me whether A is a subset of B or B is a subset of A. Which one is true? A subset of B, B subset of A. Anybody? B is a subset of A? Yes, B is a subset of A. B is a subset of A. Correct. B is a subset of A. Right? Write down your note point. Each set is a subset of itself. Each set is a subset of itself. प्रत्येक set is a subset. Each set is a subset of itself. Note point 2. Null set or empty set. Null set is the subset of null set is the subset of every set. Null set is a subset of every set. Null set is the subset of every set. Okay, note point 3. If it is given A is a subset of B, then if X is an element of A, implies X is also an element of B. If A is a subset of B, means each and every element of set A is also an element of B. If it is given that A is a subset of B and X is an element of A, then eventually X will be an element of set B, right? Then write down equality of sets. Equality of set, two sets A and B, two sets A and B are said to be equal two sets A and B are said to be equal if A is a subset of B and B is a subset of A. If A is a subset of B and B is a subset of A, then we can say that A and B are two equal sets. For example, A be the set containing the elements alpha, beta, gamma, and B be the set containing the same elements alpha, beta, gamma. Here we can say A is a subset of B and B is a subset of A. Hence, A is equal to B. Okay. Write down a note point. To prove, note point, to prove two sets A and B are equal, to prove two sets A and B are equal, it is enough to show that to prove two sets A and B are equal, it is enough to show that A is a subset of B. Or note 3. Note 3 is if A is a subset of, it is given that A is a subset of B. Okay. Suppose it is given A is a subset of B and 1 is an element of set A. 1 is an element of set A. If A is a subset of B, then each and every element of set A is also an element of B. If 1 is an element of A, this implies 1 also belongs to B because each and every element of set A is also an element of B. Right? To prove two sets A and B are equal, it is enough to show that A subset of B and B subset of A. If you can show A subset of B and B subset of A, then A is equal to B. right? Just a minute. Then write down cardinality or cardinal number of a set. Cardinality or cardinal number of a set. Cardinality or cardinal number of a set. The number of elements in a set is called its cardinality or cardinal number. The number of elements in a set is called its cardinality or cardinal number. If A be a set, then its cardinal number if A be a set, then its cardinal number is denoted by mod A or NA. That is number of elements in A. If A be a set, then its cardinal number is denoted by mod A or NA. For example, if A be the set containing the elements alpha, beta, gamma, then Na is equal to 3. Number of elements in the set is equal to 3. Usually in IITJ, it is written like this, Na, the number of elements in A is equal to 3. Okay. So one more point you have to keep in your mind. While you are counting the number of elements in a set, if an element is written more than once, that will be counted once, right? For example, if A be the set containing the elements alpha, beta, beta, and gamma, 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 you can't say the number of elements is 6. The number of element is 3. If an element is written in a set more than once, it will be counted once. Okay. Then come to equivalent sets. Equivalent sets, okay. Equivalent sets. Equivalent sets. Two sets A and B two sets A and B are said to be equivalent two sets A and B are said to be equivalent if number of elements in set A is equal to number of elements in set B. If number of elements in set A is equal to number of elements in set B, then we can say that the two sets are equivalent sets. Then we can say that the two sets are equivalent sets. If number of elements in set A is equal to the number of elements in set A is equal to number of elements in set B, then you can say that two sets are equivalent. For example, let A be the set containing the elements A, B, C, D, and B be the set containing the elements 1, 2, 3, 4. Let A be the set containing the elements A, B, C, D, and B be the set containing the elements 1, 2, 3, 4. Here number of elements in set A, number of elements in set A is equal to 4. Number of elements in set B is also 4. Hence we can say that A is equivalent to B. Okay. Again, let A be the set containing the elements alpha, beta, gamma, and B be the set containing the elements alpha, beta, gamma. Here also we can say that the two sets A and B are equivalent. The two sets A and B are equal also. So note it down. Two equal sets are equivalent. Two equal sets. Two equal sets are equivalent. Two equal sets are equivalent, but the converse is not necessarily true. But the converse is not necessarily true. But the converse is not necessarily true. Two equal sets are equivalent, but two equivalent sets may or may not be equal. Okay, then come to power set. Power set. The set of all possible subsets, the set of all possible subsets of a set is called its power set. The set of all possible subsets of a set is called its power set. And if A be a set, then its power set is denoted by PA, which is defined by power set of a is the set of all capital X such that capital X is a subset of A. Capital X is a subset of A. Just a minute, guys. Okay. Come to an example. What is a power set? The set of all possible subsets of set is called power set. The set of all possible subsets of a set is called its power set. For example, let A be the set containing the elements 1, 2. Okay. So what are the possible subsets? You know, null set is the subset of every set. Taking one element only, we can have a subset that is 1, 2, and every set is a subset of itself 1, 2. Okay. So power set of A should be written like this: phi 1, 2, then 1, 2. Right. Come to another example. Let B be the set containing the elements. So better to use another page. Okay. Let B be the set containing the elements alpha, beta, gamma. Let B be the set containing the elements alpha, beta, gamma. So what are the possible subsets of this set? Null set is the subset. Taking one element at a time, we'll have the subsets alpha, beta, gamma, and taking two elements at a time, alpha, beta, alpha, gamma, then beta, gamma, then taking three elements, all the elements, that is alpha, beta, gamma. Okay. So power set of B is written as like this. You should not write phi within curly bracket. If you write phi within curly bracket, then this will not represent the null set, it will represent a singleton set, right? So come to a note point. If cardinality of A is equal to n, if cardinality of A is equal to n, then cardinality of power set of A is equal to 2 to the power n. If cardinality of A is equal to n, Then cardinality of power set of A is equal to 2 to the power n. So A contains n elements. So its proof is in combinatorics. Okay, if you know permutation and combination, otherwise note it down. So number of elements in the power set of A will contain NC0 plus NC1 plus NC2. I think you don't know what is combination. Sir, class कब खत्म होगा? कब खत्म होगा? Class is 9 सरियो, है ना? So full second session will start from 9:15 to 10:45, and today's second session will be amazing one because I will teach you the operations on sets. Then I will solve some JEE previous year questions. Okay. So the cardinality of a power set of A, the cardinality of a power set of A, you just note it down for the sake of completion because you don't know what is combinatorics. NC0 plus NC1 plus NC2 plus up to NCN, which is nothing equal to 2 to the power n. If A set contains n number of elements, then the power set of A contains 2 to the power n number of elements. Suppose set A contains 3 elements, cardinality of A, Na is equal to 3. Then Na power set of A, number of elements in power set of A is equal to 2 to the power 3, which is equal to 8, right? If cardinality of A is equal to n or n of number of elements in the set is n, then the cardinality or number of elements in the power set of is equal to 2 to the power n, right? So for what we have covered what is a set, then element of a set, then how to represent a set, then after representation different types of sets, null set, singleton set, subset, superset, then cardinal number of sets, then equivalent sets, then equality of sets, then power set of a set. So this session, I think this session is over now. The second session will start exactly at 9:15. So guys, join exactly at 9:15 and the second session will be amazing one, right? Kalikot Higher Secondary, Krishnamayi, Lipsa, NSCB, Pratisha Mahapatra, Priyanka Priyadarshini, Ranji Higher Secondary, Vishmagiri, Shobhita, Shreya, Smruti, Sauradipta, Shreya, Smarnika, Yadavji. Okay. So guys, today's first session is over now. We'll start the second session exactly at 9:15. If you have not taken your breakfast, go and take your breakfast and join at exactly at 9:15. We'll start at 9:15.